We want to learn on how to use inverse methods to solve simultaneous equations of two unknowns. Here we have two equations, two unknowns, and likewise here we have two equations and two unknowns. But how do we go about this? Of course, if it were not given the condition that we should solve using matrix, we can just go ahead and use substitution method or elimination method, as the case may be. Now let's look at how we can go ahead with two unknowns using matrices. Now if we have a set of matrix A11, A12, A21, and A22 with a set of unknowns of x1 and x2, and is equal to a set of constants b1 and b2. Now if we look here now, we can see that this is a 2 by 2 matrix, this is a 2 by 1 matrix, and this is a 2 by 1 matrix, because when we multiply these two together, the result would be a 2 by 1 matrix. Now let's proceed from there. So let's call this matrix, let's call it A. Is being multiplied by a set of constants, so we call the set of constants x, the set of unknowns rather, let's call it what, x. Let's use small letter x as the case may be, capital, and is equal to a set of constants, so we call the set of constants b. Now with that done, now let's rewrite it and we say this is ax is equal to b. We know A is the matrix of coefficients, x is the constant, is a set of unknowns, and b is the constant. Now let's say we multiply both sides by the inverse of a. So we know the inverse of a multiplied by a, x is equals to the inverse of b, inverse of a multiplied by the set of constants b. Now from the rules of properties of inverse matrix, we know that A inverse multiplied by A is equals to the identity matrix. And identity matrix in this case is 0, 1, 0, and 0, 1. Now, in that case, so we know that this will result to an identity matrix I multiplied by X, which is equals to A inverse multiplied by B. Now, if we multiply an identity matrix with a column matrix, that's like a 3 by 1 matrix or a 2 by 1 matrix. So if we multiply this by x1 and x2, the result will be x1, x2. Alright, so when it is being multiplied by this, we have x1 and x2. So therefore, we are saying that it's tx, which is tx. You get what I mean? Because x is x1 and x2. So we now agree that this is x, which is equals to A inverse multiplied by B. Now this is what we are going to be applying when solving matrices with inverse method. The unknown we are looking for is the inverse of the coefficient multiplied by the constant. Now let's look at the question we are given. Let's start with question 1. We have two unknowns x and y, and we also have x and y, but we have two equations. So the first thing we need to know is that what is the unknown? Unknown is x, y, as the case may be. Some might say it's x1 and we change the y to x2. However, we want to stick to x and y because that's what the question is given. Now the set of coefficients, now we know it's going to be a 2 by 2 matrix, so it will be the coefficients of the terms x and y. So the coefficients here are 3, -4, 7, and +1. So we have 3, -4, 7, and 1, and the constant b is 1 and 23. So we have the unknown, we know the A, and we know the set of constants. So according to what we have here, the unknown, that's x here, that's x, y. So we are implementing what we see here. is equals to the inverse 3 minus 4, 7, 1. We take the inverse of this and then we multiply it by the constant of 123. So yes, we can see how this question has been reduced to this. So to solve this simple 2 by 2 question, we are going to apply this. So we take the inverse of A, multiply by B. So let's look at how we take the inverse of A. So let's recall, for a 2 by 2 matrix, right? For a 2 by 2 matrix, or let's say AB, CD, and we want to take the inverse. Let's say A is equals to this. Now the inverse of A is 1 over the determinant of A multiplied by, we switch these two terms, this will become DA, and then we multiply these two terms by minus 1, that's minus C and minus B. It's simple. However, for a 3 by 3 matrix, we know we have to first evaluate the cofactor, and then after evaluating the cofactor, we look for the adjoint, and we perform the rest operations. So now we know that A in this case is what? 3 minus 4, 7, and 1. So we have to evaluate the inverse here. Now the inverse applying this formula, okay, the inverse applying this formula is 1 over the determinant of A multiplied by 3 and 1. We inverse that to give us 1 and 3, and we multiply these two terms by minus 1 to give us minus 7 and 4. Now what is the determinant? Let's evaluate the determinant of A. The determinant here is 3 times 1 minus 7 multiplied by minus 4. So this would give us 3 plus 28, which is equals to 31. Now we have evaluated the determinant to be 31. Is not equals to 0, so it's possible for us to evaluate the matrix, the inverse rather. So that means this is divided by 31. So we know that if A is equals to 3 minus 4, 7, and 1, definitely the inverse is equals to 1 over 31 into 1, 4, minus 7, and 3. Now let's remember the question again. The question says this. Yeah. And we interpreted this to say that, oh, we have the unknown x and y to be equals to A inverse multiplied by B. And now we know that A inverse now is 1 over 31, 1, 4, minus 7, and 3. And B is equals to 123. So all we just have to do now is to perform a multiplication operation here of two matrices. Now if you look at it now, this is a 2 by 2 matrix and this is a 2 by 1 matrix. So when we multiply it all together, the result will be what? A 2 by 1 matrix, and the 2 by 1 matrix is the unknown x and y. So let's proceed. X comma y now is equal to 1 over 31, 1 minus 7, 4, 3 multiplied by 123. So let's perform the operation here. So this will be 1 over 31. We know this will result into a 2 by 1 matrix. So that will be 1 times 1. The first row multiplied by the column 1 by 1 plus 4 by 23. And this will give us a minus 7 by 1 plus 3 by 23. And resolving this, we have 1 over 31, 1 plus, okay, all together will give us 93 and 62. So therefore we multiply each term by 1 over 31, just like in scalar multiplication, where k multiplied by the element of matrix is equivalent to k, the element of matrix, after it is being multiplied. Now with that done, we know that x, y is still equals to 1 over 31 multiplied by 93 times 92, 62 rather, So this will mean that it will be 93 divided by 31 and 62 divided by 31, or 93 times 1 over 31, as the case may be. And we will have our answer to be 3 and 2. So in final, we have xy is equals to 3 and 2. Interesting. So let's take one more example on this. We know that the unknown in this case is what? X and y. The set of coefficients A is 3, 4, 6, and 8. The set of constants is simply 7, 6. So our unknown xy will be the inverse of 3, 4, okay, multiplied by b, which is the inverse of 3, 4, 6, and 8 multiplied by 7, 6. So the first thing to do is to evaluate the inverse. Now the inverse is simply 1 over the determinant of A, since we are considering a 2 by 2 matrix, okay, multiplied by okay, let's take a step backwards. We are given if A, we're following this formula, if A is AB, CD, and definitely we are saying that the inverse of A is 1 over the determinant of A multiplied in the bracket of matrix DA minus C and minus B. So with that done now, we know that the determinant is, the inverse is possible provided the determinant is not equal to 0. So let's go ahead and evaluate the determinant. We know that A is 3, 4, 6, 8, and the A inverse is equals to 1 over the determinant of A multiplied by, this is being swapped, so it goes into 8, 3, and this is being multiplied by minus 1, minus 6, and minus 4. So yeah, is it possible now? The determinant of A. The determinant of A is 3 multiplied by 8 minus 6 multiplied by 4. Now this is 24 minus 24, which is equals to 0. Oops, the determinant is 0. Definitely not, there's no inverse for this. And if there's no inverse, then there is no solution. Okay, so that means for this question of 2x plus 4y is equals to 7 and 6x plus 8y is equals to 6, we can see that there is no value of x and y which can satisfy this given equation, because there is no inverse, and once we cannot evaluate inverse, we cannot arrive at the solution. Now let me give you a quick example on this. Let's say we want to evaluate using inverse method on these two simultaneous equations. So we have 9x plus 4y x plus 2y is equals to 17 and is equals to 4. So try and solve question 3, and then we continue in the next video.